In the summer of 1944, the air crackled with tension as Allied forces prepared for one of the most significant military operations in history. The beaches of Normandy, a blend of soft golden sand and treacherous cliffs, echoed with the sounds of roaring aircraft and the distant rumble of gunfire. Soldiers, clad in camouflage and helmets, braced themselves for a battle that would determine the fate of nations. Yet among the chaos, an unexpected question lingered. How could a simple rubber chemist, often dismissed as moronic, wield the power to reshape the tides of war? This paradox highlights a deeper truth. While strategies and weaponry define battles, it is often the overlooked innovations and the invisible systems that truly dictate the outcome of wars. The Second World War was marked by fierce competition for resources, technology, and manpower. In the early years, both the Allies and Axis powers held firm beliefs about what was possible in warfare, often guided by outdated doctrines and overconfidence in their strategies. The German military, with its blitzkrieg tactics, showcased a rapid and aggressive style of combat that left many allies scrambling to adapt. They believed that speed and firepower would always dominate, leading to a series of early victories that bolstered their confidence. Meanwhile, the Allies faced their own challenges, struggling with supply lines and the logistics of large-scale operations. As the war progressed, the need for reliable materials became paramount. Rubber, a vital component in everything from tires to ammunition, was in short supply for the Allies. The Japanese occupation of Southeast Asia, a primary source of natural rubber, had cut off essential supplies. This shortage underlined the importance of innovation in synthetic alternatives, as military planners recognized that without sufficient rubber, their vehicles and weapons would falter. In this context, American scientists and engineers turned their attention to the development of synthetic rubber. They understood that the war effort hinged not just on the weapons produced, but also on the materials that supported them. However, the science of rubber production was complex and nuanced. Many believed that the challenges of creating a viable synthetic substitute were insurmountable, especially when faced with the advanced techniques employed by the Germans. The prevailing sentiment among military leaders and industry experts was one of cautious skepticism. Manuals on wartime production often highlighted the superiority of traditional methods, reinforcing the belief that synthetic rubber could never compete with its natural counterpart. Despite this, a group of American chemists, including the often underestimated figure of Charles Goodyear, began to explore new avenues. They operated with the understanding that innovation was not just a luxury, it was a necessity for survival in the war. Their laboratory environments were filled with the smell of chemicals and the hum of machines as they experimented with various formulations and processes to create synthetic rubber. This process, however, was not without its challenges. Early attempts yielded mixed results, raising doubts about the feasibility of large-scale production. Nevertheless, the urgency of wartime needs propelled these scientists to push the boundaries of what was thought to be possible. As the Allied forces prepared for the D-Day invasion, a breakthrough in synthetic rubber production was on the horizon. The determination of these chemists, working tirelessly behind the scenes, stood in stark contrast to the prevailing belief that such advancements were futile. Their resolve would soon prove critical as the Allied forces faced the daunting task of establishing a foothold in Europe. In the months leading up to D-Day, the Allies began to realize the importance of logistics and materials. The rubber shortage was not merely an inconvenience, it was a strategic vulnerability that could hinder their operations. In this environment of uncertainty and peril, the contributions of the rubber chemists became increasingly vital, though their work remained largely invisible to the broader military command. The context of the war was shifting, and the realization that scientific innovation could turn the tide became more pronounced. As the Allies prepared to launch their operations, the groundwork laid by these chemists was set to play a pivotal role in the success of their military campaign. The stage was set, and the influence of seemingly mundane materials was about to reveal itself in ways the military had yet to fully comprehend. The decisive factor that the Axis powers underestimated was the adaptability and resilience of the Allied forces. This blind spot proved crucial as the war unfolded. German military doctrine emphasized speed and overwhelming force, leading them to underestimate the Allies' capacity for innovation and strategic planning. The Nazi regime believed that their technological advancements, particularly in armored warfare and aircraft, would secure their dominance on the battlefield. As the war progressed, however, the Allies managed to pivot their strategies, focusing not just on traditional military tactics, but also on the integration of new technologies and materials. The Germans, fixated on their existing advantages, failed to recognize the importance of resourcefulness in warfare. Their rigid adherence to established tactics blinded them to the evolving capabilities of their adversaries. The German High Command often dismissed the contributions of scientists and engineers, assuming that military might alone would suffice. This cultural error led to a lack of investment in alternative materials and innovative processes, which the Allies were beginning to embrace. While the Axis powers relied heavily on their existing technologies, the Allies were willing to experiment and adapt, a key factor in their eventual success. One notable example of this blind spot was the German reliance on natural rubber for their military vehicles and equipment. As the Allies developed synthetic rubber, the Germans remained largely unaware of the impending shift in the balance of materials. This oversight would ultimately lead to significant logistical challenges for the Axis powers as they struggled to maintain their supply lines. The Allies' ability to innovate, often rooted in the contributions of individuals like Charles Goodyear and his colleagues, showcased a fundamental difference in approach. The Allied command recognized that success in warfare required not just strength, but also the ability to adapt to new circumstances. This realization allowed them to capitalize on the advancements being made in synthetic rubber production. Moreover, the psychological impact of this adaptability cannot be overstated. The Axis forces, who had initially dominated the battlefield, found themselves facing an adversary that was not only resilient, but also capable of surprising them with innovative solutions. This shift in perception began to fracture the confidence of German troops, who were accustomed to swift victories. As the Allies prepared for major operations, the importance of materials like synthetic rubber became increasingly evident. The Axis powers, caught in their own mindset, failed to understand that the war would be won not just through firepower, but through a combination of strategy, innovation, and the ability to leverage resources effectively. This miscalculation would ultimately cost them dearly. The culmination of these factors revealed a profound truth. The Allies' ability to innovate and adapt was a critical element that the Axis powers could not afford to overlook. As the war entered its later stages, the consequences of this blind spot became starkly apparent. The tide was turning, and the resourcefulness of the Allies was beginning to shine through. In the face of overwhelming odds, the Allied forces demonstrated that success in warfare was not solely defined by traditional metrics. The ability to pivot and embrace new technologies would prove to be a decisive advantage, one that the Axis powers failed to acknowledge until it was too late. At the heart of the Allies' success lay the development of synthetic rubber, a technological breakthrough that transformed the logistical landscape of warfare. This innovation was predicated on three key pillars: the chemical composition of synthetic rubber, the production processes utilized, and the strategic implementation on the battlefield. Each of these elements played a critical role in converting the Allies' resource limitations into a decisive advantage. The first pillar was the chemical advancements in creating synthetic rubber. Scientists developed new formulations that mimicked the properties of natural rubber, allowing for similar performance in a variety of applications. This innovation meant that the Allies could produce rubber on a scale previously thought impossible. The ability to synthesize rubber from readily available materials shifted the dependence away from natural resources, which were vulnerable to enemy action. The second pillar was the production process itself. Allied chemists established efficient methods for synthesizing rubber, utilizing mass production techniques that allowed for rapid scaling. This process not only improved the quantity of rubber produced, but also reduced costs significantly. The integration of these methodologies into existing manufacturing systems enabled the Allies to meet the growing demands of their military operations without being hampered by supply chain disruptions. The third pillar was the strategic implementation of synthetic rubber across various military applications. Tanks, trucks, aircraft, and equipment all relied on rubber components, and the availability of synthetic rubber meant that the Allies could maintain their operational tempo. From tires to gaskets, the impact of synthetic rubber was felt across all fronts, directly translating into enhanced mobility and operational effectiveness. The Axis powers, on the other hand, struggled to adapt to this shift. Their reliance on natural rubber left them vulnerable to supply disruptions, particularly as the war progressed and their resources dwindled. The inability to pivot to synthetic alternatives meant that German military operations faced increasing logistical challenges, hampering their effectiveness on the battlefield. Moreover, the Allies' mastery of synthetic rubber production set a precedent that would define military logistics for years to come. The lessons learned during this period would shape post-war manufacturing and resource management strategies, illustrating the importance of adaptability in warfare. Those who lacked the foresight to embrace innovation found themselves at a significant disadvantage, unable to keep pace with the evolving demands of the conflict. The transformation brought about by synthetic rubber was not merely a matter of quantity, but of quality. The durability and reliability of synthetic rubber components compared favorably to their natural counterparts, enhancing the overall performance of Allied vehicles and equipment. This improvement translated into greater operational success, as forces equipped with reliable materials could execute their missions with confidence. As the battlefield conditions evolved, the Allies' ability to produce and implement synthetic rubber became a cornerstone of their strategy. This technological advantage played a crucial role in maintaining momentum and ensuring that supply lines remained intact. The combination of chemical innovation, efficient production, and strategic application of these materials ultimately shaped the course of the war. The impact of synthetic rubber extended beyond immediate military applications. It laid the groundwork for future advancements in materials science, influencing industries far beyond the realm of warfare. The successful integration of synthetic rubber into military operations demonstrated the potential for scientific innovation to drive change on a systemic level. Ultimately, those who failed to embrace this technological evolution found themselves left behind as the Allies forged ahead with newfound capabilities. The ability to synthesize rubber not only changed the logistics of the war, but also redefined the very nature of military readiness and adaptability in the face of adversity. On June 6, 1944, the world watched as Allied forces launched the largest amphibious assault in history, known as D-Day. The beaches of Normandy, with their heavy surf and fortified cliffs, became the backdrop for a pivotal moment in World War II. As dawn broke, American, British, and Canadian troops landed under a hail of enemy fire, their determination unyielding despite the chaos surrounding them. In this high-stakes environment, the supply of synthetic rubber proved critical. As Allied vehicles rushed ashore, equipped with tires made from the newly developed synthetic material, they faced fierce opposition from entrenched German forces. The initial waves of soldiers battled against not only the enemy, but also the challenges of navigating rough terrain and broken machinery. The Allied command had recognized the importance of logistics in this operation, ensuring that their vehicles were equipped with synthetic rubber tires. As the day unfolded, the reliability of these materials stood in stark contrast to the difficulties faced by German forces, whose supplies were dwindling. The Allies began to advance, pushing inland despite the fierce resistance. In a pivotal moment, a convoy of Allied tanks, outfitted with synthetic rubber components, surged forward, breaching the German defenses. The psychological shock among German troops was palpable as they witnessed the effectiveness of Allied innovations. For many, it became clear that their traditional methods were no match for the resourcefulness of their adversaries. As the battle raged on, the impact of synthetic rubber became increasingly evident. Vehicles that once would have struggled with flat tires or mechanical failures now moved with confidence across the battlefield. The Allies' ability to maintain their momentum on D-Day was bolstered by the logistical advantages provided by synthetic rubber, allowing them to sustain their offensive. The Germans, caught off guard by the rapid advancements of the Allies, struggled to adapt. Their reliance on natural rubber left them with fewer options as their supply lines faced increasing pressure. This inadequacy became a critical turning point as the Allies capitalized on their technological edge to push forward, gaining ground and establishing a foothold in France. The chaos of battle transformed into an unfolding narrative of innovation versus tradition. The Allies' successful landings and subsequent advances were not just a testament to military might, but also to the ingenuity that had been underestimated by their adversaries. The realization that they could not win using outdated tactics began to sink in for the German forces. As night fell on D-Day, the beaches of Normandy were a testament to the sacrifices made and the innovations embraced. The victory achieved that day was a direct result of the Allies' ability to adapt and leverage the advancements made in synthetic rubber production. It was a shift that not only changed the course of the battle, but also signaled a broader transformation in the nature of warfare. The success at Normandy marked a turning point in the war, illustrating that the outcome was not solely determined by firepower, but also by the ability to innovate and respond to challenges. The Allied forces emerged from the beaches not just as victors, but as pioneers who had proven the value of adapting to the realities of modern warfare. The arithmetic of victory in the Normandy campaign was stark and revealing. The Allies' ability to produce synthetic rubber at scale provided them with a decisive advantage in both logistics and operational effectiveness. Numbers tell a compelling story of how this innovation translated into battlefield success. By 1944, the United States had ramped up its synthetic rubber production to approximately 800,000 tons annually. This output enabled the military to equip a significant portion of their vehicles with reliable rubber components, ensuring operational readiness when needed most. The ability to produce such quantities not only met military demands, but also allowed for a strategic reserve. In contrast, German production of natural rubber was severely hampered by Allied bombing campaigns and resource shortages. By the same year, their output had dwindled to around 400,000 tons, leaving their military with a critical shortfall. This disparity in production numbers translated directly into operational capability, as the Allies could support more vehicles and equipment than the Axis forces. The impact of these numbers extended beyond mere quantities. For instance, the durability of synthetic rubber allowed vehicles to maintain operational effectiveness over longer distances. Studies indicated that Allied vehicles could travel up to 20% farther on synthetic rubber tires compared to those using natural rubber, providing a crucial edge in mobility during critical operations. Furthermore, the Allies' ability to produce synthetic rubber meant they could replace damaged components quickly. In the heat of battle, where rapid repairs were essential, this logistical advantage allowed for sustained pressure on the enemy. The ability to replace tires and other rubber components in a matter of hours rather than days significantly impacted the flow of the campaign. As the war progressed, the Allies' investment in synthetic rubber production also yielded benefits in terms of cost. The production cost per ton of synthetic rubber was approximately 30% lower than that of natural rubber, allowing the military to allocate resources more efficiently. This financial advantage translated into enhanced strategic flexibility, as available funds could be redirected toward other critical areas of the war effort. The logistical framework built around synthetic rubber also facilitated the movement of troops and supplies. With more reliable vehicles, the Allies could transport troops rapidly to where they were most needed, often outpacing the enemy's response time. This ability to maneuver effectively was a significant factor in maintaining the initiative during key engagements. The numbers highlighted the consequences of strategic decisions made by both sides. The Allies' foresight in developing synthetic rubber production not only addressed immediate wartime needs, but also laid the foundation for future military logistics. In contrast, the Axis powers' failure to adapt to changing circumstances left them vulnerable as they struggled to maintain their operational capabilities. As the war drew to a close, the arithmetic of victory underscored a broader truth. The ability to innovate and adapt was paramount in determining success. The numbers reflected a shift in the balance of power, illustrating how technological advancements, when effectively harnessed, could reshape the landscape of warfare. In the final analysis, the mathematics of production and logistics played a critical role in the Allied victory. The success achieved through synthetic rubber was a testament to the power of innovation and the importance of adaptability in the face of adversity. The systemic consequences of the Allied victory in Normandy extended far beyond the immediate battlefield. The success of synthetic rubber production marked a significant shift in military doctrine and resource management, reshaping the landscape of warfare for years to come. The collapse of the myth that traditional materials were superior to synthetic alternatives became evident as the Allies demonstrated the effectiveness of their innovations. Military planners began to recognize the importance of investing in research and development, leading to a renewed emphasis on scientific advancements in the post-war era. This change in mindset laid the groundwork for future technological breakthroughs that would define the Cold War and beyond. As the war came to an end, the lessons learned from the reliance on synthetic rubber were integrated into military logistics. The understanding that adaptability and innovation were key to success became a fundamental principle of post-war military strategy. This shift had a profound impact on how nations approached resource management and military preparedness in the years that followed. The legacy of synthetic rubber production extended into civilian industries as well. The advancements made during the war spurred growth in the chemical industry, leading to the development of new materials and manufacturing processes. This evolution not only benefited military applications, but also transformed consumer products, laying the foundation for modern industries reliant on synthetic materials. Furthermore, the collaboration between scientists, engineers, and military leaders during the war established a model for future partnerships between academia and industry. The successful integration of scientific innovation into military operations demonstrated the value of interdisciplinary approaches to problem solving, fostering a culture of collaboration that would shape technological advancements in the decades to come. The post-war period also witnessed a re-evaluation of military priorities. Nations began to invest in research and development, recognizing that the ability to innovate could provide a strategic edge in future conflicts. The lessons learned from the synthetic rubber experience became a driving force behind new defense initiatives aimed at harnessing technological advancements to enhance military capabilities. The impact of synthetic rubber production was not limited to the realms of warfare and industry. It also influenced environmental considerations. The recognition that synthetic alternatives could reduce dependency on natural resources prompted discussions about sustainability and resource management. This shift in perspective laid the groundwork for future environmental policies and practices. As military forces adapted to the realities of modern warfare, the importance of materials science became evident. The innovations sparked by the necessity of synthetic rubber production opened doors to further research in various fields, leading to advancements in areas such as polymer science and materials engineering. The lessons learned from World War II would resonate for generations, shaping the future of technology and warfare. In summary, the systemic consequences of the Allied victory in Normandy were profound and far-reaching. The success of synthetic rubber production not only transformed military logistics, but also influenced post-war industrial practices, military doctrine, and environmental considerations. The legacy of innovation established during this period would continue to shape the course of history long after the guns fell silent. The question that began this exploration, how could a moronic rubber chemist alter the course of war, now finds a transformative answer. It wasn't the best rubber that won, but the best system of innovation and adaptability that determined the outcome. The lessons of World War II continue to resonate today. In a rapidly changing world, the ability to innovate and respond to challenges remains crucial. What other overlooked innovations might hold the key to future victories?